So welcome everybody. Here's our roadmap we wanted to follow and we've come a long way. In today's session, we are going to learn about classes and object. By the end of this session, you will know how to create custom classes or user-defined classes and use them to create our own types of data structures. So let's begin. I want to start by revisiting something we have seen multiple times. I've already introduced you to some of the popular programming approaches in Python. So this might seem repetitive to you, but there's a purpose to this. The approach we adopted when we started learning was the strictly top-down procedural approach. Then we moved on to functional approach where we created functions to create maintainable software. The functions being equivalent to building blocks or Lego pieces that fit together to achieve a targeted outcome. In today's session, we will learn about object-oriented approach or OOP for short. In OOP, there will be classes that act as blueprints to create new objects or instances of those classes. Classes will have methods and attributes. The method will define how certain objects will behave. An attribute indicates the state of that particular object. For example, we can create a class called dog and define its state and various behaviors. We can then use that class definition to create multiple instances of dogs. Those are the actual dog objects that we create. And all of those will have similar attributes and behavior based on the class definition. So pop quiz number 1. Where are classes and objects? Have we seen any of these classes or objects so far in all our sessions so far that we've learned in Python? No one wants to take? Functions are classes?
No, function type or something like when we're doing something.
Yeah. Okay,
yeah,
so
yeah.
Yes, and that is correct. In Python, basically everything is an object. Remember this phrase, everything is an object, okay? And I'm going to explain later, but in a nutshell, like Samir said, we started with a string data type, hello, right? From day one, we've been doing printing hello world and all that example. And when we see type of those kind of objects, we will see what kind of classes they are inherently using. And we have seen different data types. All of those are basically different types of objects. For example, hello is a string, like I said, and then 300,000 is an integer data type. So all these are different types of objects. So how do we distinguish, or is there any distinction between classes, instance, or an object? Are the terms same?
Well, there should be, because we just said everything is object, right?
Okay. Anybody else?
I think class is the instance and objects are the subset of the class.
Okay. So no, those are not all the same. Instance and object are referring to the same thing. Those are created based on the blueprint, which are the classes. So classes are like the template on that defines how I want my object to be created or how the structure should look like. And when we create those using those classes, the objects that are created are the instances. So that's the difference.
Not everything is the object in Python then.
Classes by themselves are also considered object. If you look at documentation, it clearly says classes are also objects. So everything is object. But then there is a distinction between what classes are and what we call instance and objects. I know this might be a little confusing, but when we say instance and object, basically they refer to the same thing that are created when we use class. And that not only applies to Python, but this concept is like even with other languages that support OOP programming. Okay, so let's move on, and I want to bring you back to this chart. I know you've seen this many times, and I keep going back to this to show you that Python supports a number of different kinds of data. What we have got here is integers, floats, string, lists, dictionaries, all these collections. But basically, we have a set of primitive data objects built into Python. And each one of these examples that I have on my screen is an instance of that object. For example, the number 1432 is an instance of an integer data type. And every object has few pieces. To understand this, let's take an example of a list, 15399 here. When we define a new list object and try to print its ID and type, we can see that it will give us memory address where it is stored, and the type is called list. So we know the object that variable A is pointing to has its value and its ID or memory location. But more importantly, every object has a type. Every object has an internal data representation that we as users do not need to worry about. And this concept is very important. For example, we do not need to worry about how the different numbers or elements in a list or a tuple or a dictionary for that matter are usually stored in a memory. We do not need to know the internal algorithm implemented and should not worry much about it either, because they are already implemented for us as a class. Every object also has a set of procedures or methods for interaction with the object. For example, class list has built-in length function or sort methods that we can use on any instance of list data type. We saw this all these multiple functions. We used them in examples in one of the sessions earlier. So these are built-in methods or functions that came with this built-in data types or classes. So every time we instantiate those type of classes, they come with all these methods that are already given for us. So let's define classes in a more formal way, and then we are going to see some syntax and example codes to make this idea more concrete. A class is a user-defined blueprint or prototype from which objects are created. Class provides a means of bundling together functionality and methods for attributes. Creating a new class creates a new type of objects, allowing new instances of those type to be made. So a class is like an object constructor or a blueprint for creating objects, sort of like template or a mold to create new objects in programming. And we'll see a lot more example on what exactly we mean later on. But each class instance can have attributes attached to it for maintaining its state. Class instances can also have methods defined by the class for modifying those states. For example, in this screenshot, we see a new class of type apple being created that has attributes shape, size, and color. And then there may be methods to grow the apple, ripe the apple, and when the apple is old enough, it falls off. So all these are given by method associated with apple class. These describe new functions or process by which we can change the attributes or state of the object that we create. From the class definition or template, we can create a new instance or object of type apple. When doing so, we may give initial values to those properties like size and use the method like grow to change the size and make it behave like it is growing in its size, or use ripe to change its color. So hopefully that gives you some idea. Let's see the syntax. The simplest form of class definition looks like this. In Python, you define a class with keyword class, and that is going to tell us we're about to create the definition of a new class. The class keyword is followed by the actual name of the class that we are defining. By convention, class name begins with a capital letter and follows camel casing. This means that the first letter of each word in the class name should be capitalized, and there should be no underscore between words. This convention helps improve code readability and consistency in programming projects. In practice, the statements inside a class definition will usually be function definitions, but other statements are allowed as well, and sometimes useful. Now notice the colon sign at the end of line 1 and tab or white spaces at the beginning of each subsequent lines. The colon marks the end of class definition line and the beginning of the class's body. The entire body of the class definition should be indented with 2 spaces, 4 spaces, or a tab. This is how the Python interpreter will know whether the statement is or is not part of the class definition. Just like in functions we learned in previous sessions, the colon and tab are very important part of the syntax in class as well. Here's an example of a new class definition. The class name is myClass, and it has only one attribute, I, and one method, f, that only returns a printout. So in last session we learned creating custom functions, and almost all useful classes will have some kind of function definition within its body, and those functions are also called methods of the class. So here's the class. myClass is the name of that class. It has one attribute and then one function or method. That function only returns a string as output. That is all it is doing. Very simple. The argument self here is just there to indicate that the method is referencing the class object itself. Self is not a keyword. You could use any other name instead of self. We are going to talk a bit more about self in a minute. The main body of the program begins below the class definition, usually after 2 line breaks in between and without the indentation in the front. If we need to create an object using the class, we can do so by simply calling the class name in our code and assigning a value to the parameters, if any. In this case, we do not have any parameters, so we do not assign any in the bracket. This can also be followed by further program statements. In this example, variable x will now point to a new object of class myClass, and we can access the data attributes and method defined in that class using dot notation. The only operations understood by instant instance objects are attribute references. There are two kinds of valid attribute names: data attributes and method attributes. So since I is a data attribute, x.I gives the attribute of that particular object x given by the class definition. And similarly, x.f is the function f that is being called for this object x, and that f is defined by the class itself. Every object that is created out of this class will have the attribute I and function f built into them. Any questions?
Yeah, just trying to understand the code here. So we have a class, my class, right?
Yes.
So we have the assigned to I, and def.
I is just a variable name, right? It could be anything. In this case, it's an integer number.
Right.
And then it has a function within that class. So you see,
what is def?
Def is how we define a function.
Okay.
Class,
okay.
Keyword class is how we define class. Def keyword is how we start definition of a function or method.
Function, okay.
So with this indentation, this function is within the definition of this whole class, my class.
Okay, yeah. So in the statement, so we have another variable x, right?
Yes.
So x, we have assigned that to my class, right?
My class, this bracket, right? Remember in the syntax of class definition, there is no bracket. But here we have a bracket. So that means I am trying to create a new object out of this class.
Oh, okay.
So when that gets created, that object will be assigned to this variable reference, x.
Okay. Oh, whatever the object is created.
Yeah, from the right side, it gets assigned to the container variable in the left side, right?
Okay.
We've learned that from session 2. We've been doing this for.
And whatever comes out of that class, and then we are printing that.
Printing x is now referring or pointing to the object of this class, right? So it's some object here, and object has some attribute, right? Remember, I is the attribute.
Right.
So how we can access this attribute of that particular object that we just created is by doing x.I.
Right, x and I. X.I. So we are printing that variable and the I.
No, we're just printing the variable I of that particular object.
Okay.
Yeah, and we'll see examples later on.
Okay.
And then in this one here, print x. Since x is only the object, right? It's pointing to an object, so you will only say it's an object type.
Right.
And then here in the last line, it is pointing to this definition function f within the class. So the object x has that class as well because it comes from the definition of the class.
Okay.
So we are trying to access that method within the object that was created.
Okay, let's see the example.
Yeah. So can we create a new class from an existing class?
We should.
Okay. And the answer is correct. Yes, a new class can be inherited from an existing class. And in fact, all classes inherit from object type in Python. So object is the master of all other subclasses. It's the base for every other classes that are created in Python. Here we have to identify which one is a function call and which one is an instantiation of a class, or where I'm trying to create a new object versus where I'm calling a function.
To me, they look the same.
Anybody else?
Oh, wait, with the x, my function. Okay, this is my function.
Mm-hmm.
It's class, I think.
Yeah, one is capitalized, one is not. One says function, one says class. So which one is a real function and which one is an instantiation of a class? How do you know by seeing this syntax?
So my function is a class.
Okay, what makes you say so?
Because it's capitalized. That's all I can say.
Okay, and that is the correct answer. By convention, function names are all small letters, as we saw in previous session when we did user-defined functions. And today I just told you that by convention, name of a class begins with a capital letter with camel casing, right? So in the first one, I have capital M, capital F, no underscores in between those words, my and function. And that tells me, although the word includes function in that name, don't get confused with that name, because if I go by convention, which we all should, this should be a call to a class or creating an object based on a class my function.
So you are trying to confuse us by saying
Yes.
Opposite, yes.
The point is you have to follow the convention of naming convention that's already set out there. Every programmer follows that naming convention. And if you do not, you will get confused and you will make other programmers confused when they see your code.
Yeah.
There's one more thing I want to tell you on this. So if you are confused on which one is which, you can always print the name of those to see if it is in fact a class type or a function. So here my function was a class definition, and then when I did print my function, it tells me it is a class. Versus here I defined a function called my class, and when I print my class, it's saying function my class at that location, memory location.
So the system only differentiates by whether it is capitalized or not capitalized.
No, the system differentiates based on this keyword that you use, class and def keywords.
Oh, okay.
So to define that, this is the purpose why I included this quiz in this session. So last in the user defined function session 2 sessions ago, I think we created our own function using def keyword, and this syntax looks very similar. The only difference, as far as I'm concerned, in this example here, is the keyword that I use here is class instead of def keyword in the function definition. So the syntax is very close. Once you understand how functions are built, it is very easy to step ahead and understand classes, because classes include making functions within them. Make sense?
Yes.
Okay. Anybody has any question before I introduce you to other concepts? All right. If not, let's move on. There are 4 basic principles of object-oriented programming, and this applies to not only to Python but other programming languages as well. The first of them is encapsulation. Encapsulation describes the concept of building data and methods within a single unit or capsule called a class. So for example, when you create a class, it means you are implementing encapsulation. The goal of encapsulation is to bind all data members, like instance, variable, attributes that we saw earlier, and methods into a single unit. The second one is abstraction. This is another key concept in OOP that involves hiding the complex implementation detail of a system and exposing only the necessary and relevant features to the users. The goal of abstraction is to reduce complexity and increase efficiency by allowing users to interact with the functionality without needing to understand the underlying implementation. So we are bundling data and methods within a single unit while also hiding some of the details of the objects from other objects, and that concept is abstraction. This information hiding is to ensure that an object's state is always valid by controlling access to attributes that are hidden from the outside world. And I'll show you example, there's a good example of this later on. Another core concept in OOP is inheritance. This is mechanism that allows you to create a hierarchy of classes that share a set of properties and methods by deriving a class from another class. Earlier I told you everything is created from a base class object, so that is primitive example of inheritance. Inheritance is a capability of one class to derive or inherit the properties from another class. The goal of inheritance is to be able to quickly create a child class, also called a subclass, from a parent class, also called a superclass or base class, without having to rewrite all the implementation details of the base class. Developers only need to add and implement the newer functionalities with assurance that the data attributes and methods from the base class are also already usable in the child class. Next, and the last one, is polymorphism. That means having many forms. That's a literal dictionary meaning. In programming, polymorphism means the same function name but different signatures being used for different types. The key difference is the data types and number of arguments used in function. The goal of polymorphism is to be able to reuse the same function in various forms for different classes or objects. Let me emphasize that again. The goal of polymorphism is to be able to reuse the same function in various forms for different classes or of objects. Okay, so what's an example? An easiest example I can think of is the length function to get the length of any sequence that we have seen so many times. For example, it works well with a string data type to return the number of characters in a string. It also works equally well with a list or tuple to return the number of items in them. So we have one common function called len function that does different things when used with different data types, and that is what polymorphism stands for. So let's talk about dunder method or magic method. Remember earlier I mentioned that all classes inherit from objects, which is the base for all classes. I also mentioned object class has methods that are common to all instances of Python classes. Dunder method, short for double underscore, methods are special methods in Python that have double underscores or underscore at the beginning and at the end of their names. These methods are also known as magic methods because they enable the customization of certain built-in behavior of objects. So let's take a quick look at very few common built-in Dunder methods. The first is init method, that stands for initialization. It initializes a new instance of a class. It's also called a constructor method. This method is automatically called when we try to create an object out of a class definition. The other is len function that returns the length of the number of items of an object. For example, when you have a list, calling the len function that we already know is equivalent to calling the dunder len method on the same object. The next one is string method, str, which returns informal or nicely printable string representation of object. We will see an example of this particular one later on. And the last one I have is repr, a representative method. This returns an official string representation of the object, ideally one that could be used to recreate the object itself. There are obviously other numerous magic methods. These allow classes to implement and interact with Python's built-in operations, such as arithmetic operations, string representation, and attribute access. We won't be or cannot cover all of those, but these are just to give you some hints on what they are and where they exist. So let's talk about self, the word self. Earlier I introduced you to self, and let's understand a bit more in detail about it. In short, the self parameter is a reference to the current instance of the class and is used to access variables and methods that belong to that class, including init method that we just talked about. Parameter self is used in functions that are methods of the class as a placeholder for future instance names. It is always the first parameter. The reference self is analogous and partially equivalent to this word, this, this, in some other programming language such as Java. Unlike other languages though, we need to have it explicitly as an argument when defining method, including init method. So every method inside the class definition will start with reference to itself or reference to its object, and that reference usually is indicated with the word self. It doesn't have to be. That's the point I want you to understand. The point is, self is a convention and not a Python keyword. The name can be different, but this is advisable to use self because it increases the readability of code. Again, everybody else will be looking for a self, and when you don't use self, you may confuse other programmers who see your code later. Or even you might be confused a few years down the road and wonder why I did not use self. Make sense? Okay, here's another pop quiz. What are fundamental concepts of OOP? Any takers? Okay, we talked about this. There are four key concepts in object-oriented programming. Those are encapsulation, abstraction, polymorphism, and inheritance. Can a class initialize an instance of another class as its member?
The inheritance concept, right?
No, not inheritance. Two classes can be mutually exclusive, not depending on one another. And the answer here is yes. A class can have another class as its member, given the class structure allows membership. We have seen example of this. For instance, the built-in class list can have number of elements where each element can be of any data type, including integer, string, another list, a dictionary, tuple, anything, right? So there's a class, object of a class, and that object has another instances of other data type or other classes within it itself. And even in our built-in, even in our custom-built classes that we define, we can incorporate other objects of different type within them. Okay, so moving on, what are main types of inheritance? There is single inheritance. This enables the derived class to inherit properties from a single parent class, thus enabling code reusability and the addition of new features to existing code. The original class is called the base class or a parent class or a superclass of the child class, which is derived class or the subclass. Second type of inheritance is multi-level inheritance. It is combination of multiple single inheritance that we saw earlier. Feature of the base class and the derived class are further inherited into the new derived class. This is similar to a relationship representing a child and a grandfather. There's an intermediary class, and then that is used as parent class to create further child class. Now this second child class will inherit everything from here, which also inherits everything from here. And that inheritance doesn't go other way around. It's just one way, from the parent to the child. Okay, the third one is hierarchical inheritance, where a single class can create multiple child classes of different types. More than one derived class are created from the same base class in this case, and that's why called hierarchical inheritance. In this case, we have a parent base class and multiple derived classes. And the last one is multiple inheritance. When a class can be derived from more than one base classes, this type of inheritance is called multiple inheritance. In multiple inheritance, all the features of the base classes are inherited into the derived class from both this and this. Okay, so that is all the presentation I have. Let's move on to the coding. I shared this Colab with you, and there's a bunch of exercise here. Let's go start with the simplest class. So the first example I have is a skeletal class with nothing in it, just a pass statement. That basically means developer has yet to implement this class, and they're just framing it or making a skeletal so that it can be implemented once the requirement comes in, maybe later, right? So that's the practical example of when this can be useful. So let's run this. No output. We are just defining the class, and here I am calling that class to create a new object called sk. And then when I do print type of skeletal, it gives me class type. So skeletal is a class. And then when I print sk, it gives me the object created at this memory location. So sk is an object and skeletal is a class. Another example here. This is a simple example of class called animal. And the name is animal_1. And it has one data attribute and two different functions or methods within its definition. The data attributes is for age, but instead of saying age, I'm saying years old. And the first function here is incrementing age, that will add +1 to that age and print out happy birthday when this function is invoked. The second function is age. It only returns how the data attribute, the value of the data that was stored. So when we run this, we get nothing, no output. Now, why I'm giving you this? Because I wanted to show you encapsulation with this. In this example above, the class animal_1 bundles data here and the methods here. So it bundles data and method together within the single unit animal class as a single unit or a capsule of the type class. The goal of encapsulation is to bind all the data members, instance variables, and the methods into the single unit. So that's the core concept of OOP, encapsulation. So let's also understand abstraction a little bit with this same example. We have this definition animal1, so I'm creating an animal x with that definition, and then with the dot notation for that object x, I am accessing different values. This is accessing data value, this is accessing the function that was inside that class definition. Incrementing age is another function. So first I print age, and then I increment age. Then I also access the same age with the data attribute directly without using the function here. But then I also use a function to access the same variable years old. Okay, so when I run this, it should first give me 0, which is the default years old when the object is created. And then the method age is also trying to access the same variable, which also happened to be 0. Now I increment the age and it shows happy birthday because of the increment age function call, which has this return statement. And then when I do the years old and age again, I get the new age value, 1 and 1. Both way I'm accessing the same data attribute within that object. Confused? Any questions?
Yeah, confused, yes.
Where?
Oh, well, too many confusions. So can you explain the first one, class animal1?
Yeah, so here we are just creating a simple class, right?
Correct.
Remember, this is only class definition. Just like function definition, we only define, but we do not touch them until they are invoked, or
Correct.
the code here is trying to create or utilize that class definition, right? So all this is just defining the animal class. The animal class has one data attribute, integer value for age or years old, and then these are functions. The first function will change the age by 1 and then print happy birthday.
Why are you saying years old equals 0?
Why not?
I mean,
I could say age equal to 0, but that's the beauty of abstraction, right? I could say anything internally and you do not have to care about how it is implemented inside. That's the core concept of having classes.
okay, so that's the data attribute.
With not saying age equal to 0, I'm basically preventing you from accessing age directly when you try to do so later. Any third-party user should not be able to know, should not.
In other words, this is a starting point.
Yes, this is initialization of the class. I will talk about initialization with later on, but there's a default initialization method here. And in this case, by default, it initializes every object of animal1 type with years old equal to 0 value. Now I could manipulate that years old with these two methods. The first method increases the years old value by 1 given by this, and then every time I do that, it returns happy birthday. The second one is just a getter method.
So getter method is, how do you know if this is a getter method? How do I know?
It only returns the value, so it's a getter. We could say get age like this, get age, just to say a getter. It's a getter method.
Oh, okay.
There is a more better advanced way, but I do not want to cover that for this introductory class. You could say set age and get age to make them more readable setter and getter method. But the problem with set age is I do not want to set any age, right? I could have another method that says set age, but I also need another separate method that increment age by 1 after every birthday. So that's the increment age, and then this is the getter method.
So when you run it,
when I run it, nothing will happen. It's only the class definition, right? I have to run this to get some output.
Okay.
And when I run this, the initial age value is 0. After a birthday, the new value is 1. Remember this line 5 and 6 and 2 and 3 are exactly the same. Between those lines, I have birthday. So after birthday, the age increases by 1 value. Nothing too big, just to get started. So as I said earlier, this class allows implementation detail to be hidden and instead use age method to fetch the age of the animal, which happens to be years old as a variable name reference, and increment age method to change the age of the animal. This goal of abstraction is to reduce complexity and increase efficiency by allowing user to interact with the functionality without needing to know or understand the underlying implementation. So you as a user, when I give you this function, should not worry about what is inside. You should only be worrying about how to use this function or what functions to use when, right? What functions are available to use. Okay, so next example, base object in Python. We talked about base object. Every object is a subclass of base object eventually, directly or indirectly. So here I'm creating animal2 class, very similar to the above method. Let's see them side by side, animal2 and animal1. But here I'm doing something interesting. I am inheriting from the object superclass. Okay, so here I don't have parenthesis and no argument, therefore, but here I have an argument within parenthesis, and that argument is basically the parent class out of which I am trying to create this new class, and every other detail is same. So this class inherits from that base object class, and when I run this,
so you are inheriting from object.
Yes, here as well I'm inheriting from object without explicitly telling it, right? There is no explicit parent class I defined or wanted to give.
Right.
There's also no explicit initial method or init method, but Python does those automatically for me, even if I do not if I do not supply anything.
Okay.
And that's what I'm trying to show you here. It doesn't have init method. It has object, but the previous example did not have that as well. When I run this new one and run the same code here for animal2, I would get exact same output.
Okay, so what you're trying to say here is even if you mention object or don't mention, it's the same thing.
Yes, exactly. This is proper way of making inheritance or providing explicit inheritance. But if you do not do anything, it will be a base object or base class that gets inherited from. Okay, so let's talk about init method or constructor. I told you constructors are generally used for instantiating an object. The task of constructor is to initialize values to the data members of the class when the object is created. In Python, that method is the dunder init method. This method is called the constructor and is always called when an object is created. There are two types of constructor. The default constructor doesn't take any parameters. It only has init. Remember self, every method should begin with self, right? So even if there's no other parameter, we have one parameter, self, in those methods. Self basically refers to the object that is created itself out of this class. So don't get confused what self is anymore. What you have to remember here is I'm creating a new class type animal3 out of the object's base class, and it has explicit dunder init method for the construction of that object. And
how do you know this is a dunder?
Double underscore in the front here and the back.
Oh, okay.
Dunder basically means two underscore or double underscore.
Oh, okay.
Double underscore, short for dunder, short dunder. Okay, so everything else I think is pretty much same. When we run this one, nothing, no output. We have to create the instance, right? So here animal3, with this I'm creating an object, animal object A, and then accessing the attribute or method age of that new object, and it gives me 0 because I initialize it with 0.
Yeah.
Okay, so let's look at parameterized constructor. Here I have one or more key argument besides self in the dunder init method, and I'm giving age and
you're not going back to animal class, right?
not going back. This is, remember I started with animal 1. Animal 1 was my first class.
Oh, okay.
And then animal 2, animal 3 was the last one.
Yeah.
Now I just have animal. Okay.
Yeah.
So this constructor here has one parameter. The parameter is age, and I use that to assign value to the years old attribute of that class. So whatever is passed here will be assigned to this self years old variable of that class. Remaining methods are same. So let's run this. And then now when I try to initialize animal, I have to give the value of the age. In this case, I'm saying the age of this animal will be 10. So when I try to access the age, it will give me 10. So let's see some examples of inheritance. Recall that animal class we had just defined. There's we did not use the default constructor, but a parameterized constructor that only needs one parameter.
Dunder, right?
Yeah, this is the dunder, but it only has one parameter, age, right?
Yeah.
So that is the base animal case that I want to use to create other different types of animals. So let's see single inheritance. I'm using the base animal as my parent case to create mammals, a new class called mammal. Mammal will inherit all the properties of this animal class and also the methods that were defined in animal class. And with this new mammal class, the super method is used to initialize the parent's attributes. So this method here runs the initialization method of the immediate parent, which is the animal class. And then now
Is that animal we created, or is that did we create that animal?
Here. We just saw the example here, right?
Okay, yeah.
So that is our base class to create mammals, right?
Right, yeah.
And I added this new variable with a default value 4 legs. So mammals usually have 4 legs, right? So maybe not all animals have 4 legs. In case of mammals, they usually have 4 legs. So I defined a new variable legs equals to a default value of 4. And then a gender will be determined randomly based on choice function out of male or female. Okay, so let's start running this. There is no output again because that's just a function definition. Notice here that mammal class, when we define, does not explicitly have the same data and methods previously defined in the base immediate parent class animal. The methods we do not define here, right? We only initialize with the super initialization method of the base or the parent class, and then added new attributes that we wanted explicitly for mammal. So doing this, the mammal will get all the attributes from the animal, but not the other way around. Animal will not be getting any attributes that are now introduced to mammals. So let's say Harry is a new mammal with age 3, and when I print Harry's legs, it is basically accessing the value here and giving me 4, and the gender is male. So every time I run this, there might be new gender, but the age is by default 4.
Just curious to know. So in you're inheriting mammal from animal, right?
Yes.
As soon as you type mammal and then in the bracket animal, does the code populate by itself?
Code does
Because
code does not populate, but the mammal will be referring to whatever attributes are there in animal.
Yeah, because the animal has the same attribute, same function, everything
Yes.
the same.
Yes.
Yeah.
Without repopulating all the codes, it does that, and that's why inheritance is so powerful. The developer does not have to redefine everything for the base class.
Yeah, even if you don't write anything, don't do anything, the program understands that it has this.
Yes, just by doing this and then using the superclasses constructor.
Yeah.
I am inheriting everything from that animal class, and all I need to do is whatever is new for this particular class, I need to define them. Okay, so
whatever you new defined plus whatever it has with the animal, right?
Yeah, whatever it has with the animal comes with the super initialization method. Okay, so let's see another example here. In this case will be multi-level inheritance. So again, now so far we have, what do we have? We started with animal, and then we have made mammal out of that animal, right? As a child class. Now we go further. We use that mammal class, which was the child class, to create a subclass out of that called a dog. So dog is a type of mammal, right?
Yeah.
So now we use that mammal to create further subclass called a dog, and it will again use the super init method, which looks at the immediate parents initialization method, which is the mammals initialization method. So it creates all of those and then adds a new variable called breed for the breed of dog. And now it also has additional function or method that is called sound out. When we execute that, all it says is a print statement that prints the dog is barking. Now this method is exclusively only for the dog object, or the classes or the objects created for dog. Okay, so let's run this, and then I'm creating a dog named Flash with age 0 and the breed is Pug, right? So when I say flash.age, age is 0, he has 4 legs, and the breed is Pug, and sound out method is called, which prints the dog is barking. Any confusion? So let's see hierarchical inheritance. Okay, so I'm also creating, besides dog.
What was the previous one?
Multi-level.
One was
Multi-level.
Multi-level, okay.
Single inheritance and then multi-level.
Okay.
Now we're doing hierarchical inheritance. So here we had dog from mammal so far. I'm also creating other types of mammals. So tiger and lion come alone. Okay. So nothing new here. I'm just adding a new variable called color to the tiger, and then another new variable called mane to the lion. And I'm always setting the gender to male. So this is called overriding. Okay, so whatever was initialized, I'm overriding that in this particular class or object of lion class, all of them to be male with a mane set to a true value by default. Nothing drastically changing here, just 2 new variables. Now I'm using those classes to create 2 new objects, cat1 and cat2. And then I'm printing color of cat1 and then main of cat2. So what if I try to do cat2 dot color? Cat2 was lion, right? So does lion have color attribute? Do you think I can do that, or am I allowed to do that?
You should. This is a hierarchical.
Print cat2 dot. As soon as I do dot, you will give me all the properties or methods that are available for that particular object.
Okay.
So do you see color here?
No.
And why is that? Why do you think? Because color is only explicitly defined for tigers.
Oh, okay.
So, and lions or dogs or any other mammals or animal in general will not have that exclusive attribute that was only defined for lions.
Right. But you can add that in here.
Yeah, and when I try to do cat2.main, let's see, cat2.main is available, right? But let's see cat1. So tiger object has no attribute main, so we cannot do that.
Yeah.
So attributes and methods are explicitly only available for classes that have those attributes and methods, not outside them. That is a point of encapsulation. So the last example of inheritance is multiple inheritance. Again, remember so far what we created? We started with animal. Animal has a subclass mammal, and out of that mammal we did hierarchical inheritance with tiger and lions, right?
Right.
So here now I'm creating a new class called liger, and liger will inherit it both from tiger and lion. And very simple, I'm not doing anything else. I'm initializing and using super init method with that age variable, right? And now I'm trying to use that liger class to create a liger1 object and use that object name with the attribute or method names to see the values. Now interestingly, this liger now has both color that came from tiger and main that came from lion, because it inherited from both the objects or both the classes.
Okay.
So you see what I'm doing here?
Yeah.
Okay. Anybody confused? Liger is basically
you're just inheriting the attributes from
two different classes. Yes, liger is inheriting from. It has properties of both lion and tiger.
Right.
So that's the multiple inheritance. Those are all the examples. There are few other more complicated examples, but I didn't want to include here. If you understand this much, this is way better than where you should be at this basic understanding of Python. So let's understand also polymorphism. In programming, I said earlier, polymorphism means same function having different functionality, or same function name giving different signatures based on data types. Now earlier in the example that we created, we started with animal 1, animal 2, animal 3, animal, different classes. They had underlying implementation were similar or same, maybe, right? But those are not the same classes. Even if those are internally exact copies, those are different classes. Although they are all different classes, the internal implementation are same on these classes in these examples. Therefore, in these cases, the same method age work the same way in animal as well as it works the same way in animal 1, animal 2, all of those. However, the method name age can behave same or different. It just happens that I implemented them to be exact same in this case, but it doesn't always have to be. If they are, whether they are same or different, this is a form of polymorphism, because the same method name are used to show different behaviors or same behavior when we use that method with different objects of different types. So the same method has different forms based on the underlying class object. So that's
do you have an example for different forms for each?
Yeah, we just did, right? We started with animal 1. That is exactly what I was trying to explain. Animal 1 has age. Animal 2 is not inheriting from animal 1, right? It is inheriting from object.
Yes.
So animal 1 and animal 2 are not related.
Right.
But it also has the same exact copy of method called age.
Okay.
So this same method can be implementing different things, right?
Right.
In this case, it happens to be same implementation, but it doesn't have to be. So what I'm saying is we could use the same method name to show different behaviors based on different objects or class types. And that is exactly what is polymorphism, an example of polymorphism. Okay, so another example is attribute overriding. Okay, so in this case, I have a new class human that is also inheriting from mammal, right? But now human do not have 4 legs. So I'm redefining legs in human to now say 2 legs, but now they will also have new attributes called hands, which is also 2. And maybe human beings also have their names. So I'll add that attribute there too. So this basically we started with default leg 4 for all the mammals, but I'm overriding that value for only humans to have 2 legs and 2 hands. So I'm overriding the value of legs in this case, right? This is attribute overriding. And when you print that out, you see 2 hands and 2 legs for Tom, which happens to be female, by the way. So Python also allows method overriding in subclass. Let's see an example here. Notice that in the above definition of classes, we use multiple print statements to print the data attributes of the instance. Now I'm also adding the dunder string method here to print out all the required attributes that I wish to print in the same line in that dunder string method. Okay, so this is the first dunder method that I'm defining for person, which is inheriting human subclass. So person is further child class of the human subclass. And maybe that person also has attribute called pet. Maybe he wants to have some pet in there. Nothing doing so far. I'm just defining or the default value of none for now. But pay attention to this dunder method. For person, what I want to print is, this is f string, right? So everybody should be familiar with this by now. I'm trying to print name in title case. That name is some years old and the gender. Okay, so let's run this definition, and then here I'm creating a person. This using this class definition, I'm creating a person 18 years old with, what is that? What do you think that is? Let's run and find out. So somebody is 18 years old, female. It doesn't have a name. So because I'm providing empty string here, it doesn't show any name. Okay, so let's say Jackson, and then when we run it again, Jackson is 18-year-old female. Anybody confused here?
So where is that female coming from?
It's coming from one of the parent classes. The gender was set randomly to male or female.
Okay.
In line we say we override to male, but dog, no, let's go to mammal. Maybe there's one. Okay, mammal here. Under mammal, when we initialize the gender parameter or attribute to be randomly chosen between a male and female.
Okay, so that's coming from the mammal.
Yes. So every dog, every tiger, lion, liger, human, and person, all of those will have gender attribute.
Right.
Because they all inherit from human or mammal. Sorry.
Yeah.
So everybody understand this? Any other question here? I want you to pay attention to this string method, okay? Now, next example I'm doing is method of the parent class can now be overridden in the child class. So this method I am redefining in its child class. So person I'm using as the parent class here to create a student class or subclass. So a person.
Person. Okay.
So a person can be a student, right? So a student is inheriting all the person's attribute.
Right.
And there may be subject that the student is currently studying. So that is an attribute that I wanted to add there for the student. And with that, I'm redefining this dunder method, string method. And explicitly what I'm adding that on there on top is, at the end, I want to say this guy is studying this subject. Okay, so I have same method name, right? For this child class compared to this parent class. It's immediate parent class.
One more. We used to many times. Still want to ask you this.
Yeah.
So this super function.
Yeah.
The super function is using that dunder, right?
Initializing, yes.
Yeah.
Super.init gives you initialization of the parent class, which is, in the case of student, it is person's initialization. In the case of person, it is human's initialization. And in the case of human, it would be mammal's initialization.
Yeah. So why did we use dunder though? Why is it?
This is easier way to, instead of explicitly providing all the parameters defining like this, I use this method to quickly initialize all the variables that came with inheritance.
Okay.
So all the methods that were already previously defined in person will be automatically attached to this student as well.
Okay.
With this single line.
Okay.
And then now all I have to do is add whatever I need to extra for this student.
Okay. Got it.
Subclass. So I'm overloading the dunder string method here, right? The example that I wanted to show you was method overriding. So this is a very key concept that you have to understand when you understand when you learn about OOPs. Method overriding, because I am overriding the same method that was defined in the parent class now in the child class. Let's run this, and when I print person2, now I should print Jackson is 22 years old, male, studying math. That person was missing from the previous dunder method. So now hopefully you understand what method overriding is.
Yeah, studying self subject.
Self.subject is this, right?
Right, self subject.
So whatever I entered as subject is stored as self.subject, and that will be printed out as studying that subject. Okay, so last example here. This is an interesting example, and I have an assignment that kind of does this stuff but in a more larger scale. I want you to look at this, pay attention to this, and then try to do that example. That is the last assignment that I've given for today. If you look at the slides after I publish it to you later on. So let's understand this. Here I have a class, new class called classroom. Okay, and it has size. Now the size is assigned to self.size, and self.room is also initialized as empty list. Nothing new, right? We saw that dunder init method, and we are also familiar with list or empty list. So it should not be anything new here. Now here's a getter method, get size, and setter method, set size, right? I'm defining them just to show you an example. I have never used that further down in my code.
So on line 4 with the dunder method, we can give any parameter or
size, just one parameter, size, and that size will be used to store the value in self.size.
So what is self then?
Self is referring to the own object that will be created using this class definition.
Oh.
So any new object or classroom that I create using this definition, that object will be referred to by self. So it is basically referring to its own object.
Right.
that will be created using this class definition. It's like this. All these methods are defining or referring back to its own self, or this particular instance of this class variable. Okay, so anybody confused with getter and setter? Pretty easy, straightforward. In the getter method, I only return the value. In the setter method, I set new value to that attribute. Actually, it should be self dot size equal to that new size, because self dot size is what is in the attribute of this object. So this is the syntax for getter and setter. It's the same for other programming languages as well, how you do getter and setter. In Python, there's additional way using decorators, but we are not going to go there. So here I have a method fill classroom. So what that does is, in a for loop, I will randomly create variables, age, name, and subject, and then use those to create a new student. Okay, we had a student subclass earlier, so we already know how it looks like. It takes age, name, and subject, right? So basically we are reusing that and creating objects of student type inside this for loop. So once that student is created, it gets appended to this room, which is initialized as empty list. So basically inside this for loop, I am given by this range function how many times I want to do, defined by the size, right? So let's say classroom of 5 is the size, and range 5 will give me 0, 1, 2, 3, 4. So basically I will add 5 students with every loop inside self.room, this list.
So what is 18 and 30 on line 16?
Starting age and ending age. I want my students to be between 18 and 30 years old.
Okay.
And then these are some of the names that will be randomly picked. These are some of the subjects that will also be randomly picked. Right? So I'm setting random age, random name, and random subject to all my students. Make sense?
Yeah.
And then this last method here will list all the students from the self room list. And again, I'm calling that dunder string method to print out the student's information. Where this dunder method is coming from? It's defined under student, right? We just did that example earlier. We got this for the one particular student. Here we explicitly gave the values. I'm repeating the same stuff but randomly giving the values to initialize a student. That's the only difference, right? Make sense? So remember, I had this pop quiz where I asked you, can an object of one type have a different object of different type? And the answer was yes. Here's an example of that, right? My classroom will have multiple instances of students in it, in the classroom. This is how we simulate objects using object-oriented programming. I'm simulating.
So how do you know those are the instances of the same classroom?
Same classroom? There's only one. There's no classroom yet. I have not ran this. Yet. I'm only defining what a classroom should be look like.
Right. So those are the okay. Fill classroom is another function, right?
Fill classroom is a function, yes. Inside this class definition.
Yeah, and it has those instances, right?
Yes, inside fill classes, I'm instantiating 5 or multiple occurrences of students in a for loop.
Okay.
How many times? That is given by the size that I define when I initialize classroom.
Right.
So let's run this. In this example, I'm initializing classroom with a size of 5. So I want 5 students in that classroom, right? So size parameter will have a value of 5, and range 5 will start from 0, 1, 2, 3 all the way to 4. For each of those values, I will add a student to this self room.
So where have you defined, where have you given 5?
Here.
Okay.
So let's run that. In the first line, I create a classroom with 5 as value for the size variable. Fill classroom will call this function to create 5 different students
Okay.
appended to that self room, right? Self.room. So each time a student will be created and added to the room. And the last function is called here, list all students, to just list out all 5 of those students.
Yeah.
So what if I change that to 10? Creating a classroom of 10 now is as easy as that. Now you see the power of object-oriented programming. Now all by changing this value, I am creating 10 students and loading all of those students inside a classroom. And by calling this dunder method string for that student, I am printing each student's information one at a time.
So what will happen if you go to line 16 and make 18 and 100, for example?
Nothing much. These will vary from, the age will change between 18 to 99.
Okay.
Oh, I have to run this again. See,
Yeah.
there was 99, there's 89, 85. 100 will not appear because this will stop before 100.
Right. So you should have a lot of listing though. Oh, because you are limited with the names.
See, John is 98. Yeah, you could add a bunch of names here, or just add another, or define a new list somewhere and then pass that list as argument here.
Yeah.
If I only list one item here, then it will always be
Get
the
one.
name of Tom. Every student will have the same name.
Yeah.
Which I didn't want. I want it to look like a real classroom, so that's the way, right?